Hello everyone, my name is Eshaan Debnath. My talk will be about my project, Machine Learning Simplified, and my mentor was Jesse Stern. To many, machine learning and artificial intelligence seems like overused buzzwords. But what is it exactly? A machine learning model takes in a large dataset of inputs and expected outputs and identifies patterns within. Then, this model is used to make predictions on unseen data. Machine learning has uses in speech recognition, face ID, cybersecurity, and much more. Accordingly, these subjects have growing popularity, along with lots of practical applications. However, something peculiar is that the majority of people interested in machine learning care about the practical application instead of the inner mechanics. This is due to a few problems. The first problem is accessibility. Machine learning is built on a lot of high-level mathematics. As such, some resources attempt to present this math, and others skip it. Consequently, some of these resources are too simple and don't tell you how the learning actually occurs, while others build using knowledge of calculus. Unfortunately, there isn't much of an in-between, which discourages many kids with potential. The second problem is that there are many libraries that do machine learning for you by encapsulating the algorithms and functions. This is good for practical applications, but focusing on applications instead of algorithms leads to less research and slows the development in the field of machine learning. Now, I've been talking a lot about articles that are too detailed, but let's take a concrete example. The following example is taken from an article that attempts to explain logistic regression starting from the very basics and is supposedly for beginners. You can visit the article at the shortened URL at the top center. The first problem is that the article uses advanced terminology, such as Bernoulli distribution, as well as advanced mathematical concepts, such as matrix dot products, without explaining them in detail. This is because, like most articles, it assumes an educated and somewhat experienced audience. A second problem is that it includes complex derivations, which require significant mathematical background and are not beginner-friendly. An example can be seen on the right. The article also has two fundamental flaws. One is that it does not discuss regularization, which leads to models that lack a generalization and are overconfident in their predictions. The second fundamental problem is the graph of the cost function. While the article correctly states that the function is not convex, the image portrays it as having multiple local minima, where in fact it is guaranteed to have only one global minimum, if any. This can be deceiving for the reader as to why the cost function is modified in the first place. Clearly, such articles are too advanced for the common person to understand. I tackled this problem by making my own resource. Such a resource was built with a few criteria in mind. 1. It should be understandable and accessible to the common person with minimal high school education. Number 2. It should explain concepts using mathematics and intuition. Number 3. It should contain labs with machine learning implementations from scratch. A series like this has the benefit of not only being a great learning resource for newcomers, but also serves as a base level resource capable of providing a quick refresher of basic concepts for those who are more advanced. You can visit the first article in my series at the link provided. Note that all the articles in the series have a table of contents that link to the rest of the series. In this series, I started with the absolute basics of machine learning, gradient descent. We will go over this algorithm in more detail later. Next, I built on top of this by teaching the reader about linear regression, which takes in a set of inputs and gives a predicted output. An example of this would be trying to predict the cost of a house, which data such as square footage, number of bedrooms, etc. In the next article, I explained how to increase the speed and accuracy of such a model using concepts such as data normalization and matrices. After that, I explained logistic regression, which is used to make a decision. An output value close to 1 is positive and close to 0 is negative. Finally, the last article was dealt with neural networks. A neural network models how the brain thinks and identifies patterns within data through gaining a machine-like intuition of it with experience. Throughout all of these articles, I explained concepts both intuitively and mathematically, and also included lots of images and analogies to clarify key terms. To clarify key terms and concepts, I included a mini glossary at the beginning of the first two articles. I also included labs for 4 of the 5 articles for hands-on experience. Within these, I emphasize good coding habits and optimizations of speed and accuracy. Let's go over a quick summarized version of the first article discussing gradient descent, which is used to find a local minimum. For any machine learning model, you have something called a cost function. This measures how accurately your model fits the dataset and punishes you for predictions that are far off from their true value by returning a higher output. In any machine learning model, you work with a set of parameters. These parameters can be graphed with a cost function as the vertical axis. To begin, you choose a random point and find the gradient, which is kind of like a multidimensional form of slope. You multiply the slope by something called the learning rate, also known as the step size, which determines how big the jump will be when traveling down the slope. Finally, you subtract the current coordinates by the scaled gradient. In this case, the slope is positive, so subtracting would mean you travel in the negative x direction. Note that for a larger step size, you may make faster progress, but there will also be a possibility of stepping over and past a local minimum. Next, you repeat this descent until you reach a flat region. Here is the progression of your estimate for the minimum. Something to note about this is that you could have ended up somewhere completely different if you had chosen a different starting point. This is shown in blue. You can see how the progress occurs over time. However, in reality, you won't be able to see the entire function. Instead, you can only see specific parts of it, the parts which you compute the gradient of. On this next slide, you can see the same process in 3D. Note that you may once again end up in a different local minimum depending on your starting point. The process, however, remains the same. My research. To judge the efficacy of these articles, I performed a study using anonymous surveys. For each article, I gave the respondents a pre-test and a harder post-test. I also took a control sample of 10 people who filled out the set of questions from all 5 articles. This design was inspired by other research papers in the field of computing educational research, or CER, as well as the typical methodology of research papers in general. Note that due to a limited dataset, the gradient descent article and the other articles were analyzed separately. The gradient descent article and control sample had 10 respondents, whereas the other articles had 2 respondents. Quantitatively, the control sample shows that the post-tests were indeed harder. In addition, the disparity of scores between the control and the study sample shows that the readers did indeed learn something from the articles. Finally, despite the harder post-tests, all the readers experienced an increase in their scores, which really puts the improvement into perspective. Subjectively, despite the study group ranging around the average, they felt as if they had learned something. In addition, they felt as if my articles performed better than other ones on the internet. To conclude, my resource does perform better than other articles and thus is a good learning resource. However, it does have a few flaws. Some shortcomings include the glossary of concepts, which should instead be incorporated within, and the failure to reach a wide enough audience as initially targeted. Thank you for watching.
Hey everyone, my name is Dylan Singla and I'm a junior at the Lawrenceville School in New Jersey. I'm super excited to share with you my passion around sustainability, marine conservation, and artificial intelligence, and how I see these areas coming together. Sustainability to me is how we as a community can work to preserve the environment with compromising the ability of future generations to meet their own needs. By doing so, our part of our respective communities can come together to help preserve the world that we live in. From interning at the Shedd Aquarium in Chicago to helping preserve at-risk marine habitats in Mexico and supporting sustainability efforts at the Lawrenceville School, my passion for sustainability, marine conservation, and artificial intelligence has certainly flourished. I'm passionate about these topics and built Sustain, a website I want to help educate and inspire high school and college students about the importance of sustainability and what they can do to make a real difference in their local communities and more broadly the world. My generation is most impacted by climate change. Over the next 50 years, so it is up to us to make a difference. In order to do so, we will have to leverage learning from the past and think about new technologies such as artificial intelligence that will help the thinking and solutions to drive sustainability efforts. One of the core ways I want to educate and inspire others is through the set of 10 inspiring interviews I did with the leaders and experts from a college professor to the former CEO of a major tech company. These leaders share how they see the world evolving, what they do to advance these actions in sustainability, marine conservation, and with the help of AI. There are plenty of learnings and ideas that these leaders share on what we can do to make a difference. An overarching theme I found through all my interviews is that the time is now for change. We need to take drastic action now before more implications of former climate and other man-made issues are irreversible and it becomes too late. I think the most common point made about sustainability was that it's now or never. My generation is the last generation that can cause positive change before enter irreversible climate change. And while it's not simple, change is possible and necessary before we might not be able to live on our own planet. And if you don't think it will impact the very least, I think, and if you don't think it will impact you, at the very least, think of your kids, your future grandkids, or your great kids. The impact the climate change will have on them will be drastic. We get to the point where we will have to find alternative life on a different planet just to survive. One on the AI topic, an overarching theme was how AI was used in sustainability to predict the impact of change. AI is being used to predict our future based on our actions rather than being used in our day-to-day efforts to stop the negative change that's occurring. Today, this doesn't make AI any less impactful as it's used as the first step to solving the problem by helping identify the issues and knowing the consequences. We need to leverage the data and analytics like we've never done before to identify the issues. Like I saw in my excursion to several Mexico fishing villages, climate change affects water temperature, pollution, fishing populations, and ocean habitats, but inevitably impact fishing communities around the world. With these new AI insights, we can proactively help those communities so we can preserve their way of life and/or prepare them for new ways of making a living. How I've grown. Leveraging my network. To be able to access all the leaders I've interviewed, I had to leverage all the people I know to get connected with them, and then make a compelling reason why their time would be spent being interviewed. While I have not done interviews before, it would definitely be a different interview. It definitely was different interviewing such senior and knowledgeable people. Website building and designing a website were definitely two important skills I gained from this project. They're skills I will continue to work on throughout my life. They're definitely something I can work for in a future job. And this was a great start into opening that door to the world of designing and building websites. Converting interviews into podcasts is also something I worked on and how I've grown throughout this. I've never made a podcast before. I've never conducted an interview, and through this project with Polygence, it opened a whole new door to me, opened whole new experiences and a whole new insight on how I look at some of these websites. Sorry about that. Sorry, some of these websites and other daily tasks we see, and how much work really goes behind them, and how much work really goes behind them, and how long it really takes to get these as good as they look. So what's next for Sustain? What I'm planning to do in the next few weeks is I plan to launch the Sustain website. I want to upload a podcast maybe once per month for the next 10 months for each of my interviews. Interview 10 or more sustainability in AI leaders to carry me out through my senior year of high school. And I want to build out this idea I call sustainability in a box. Sustainability in a box is a step-by-step guide I will be creating based off of my information from the interviews. And it will explain to high school, elementary, middle school, and college students, as well as the university themselves, how they can become more sustainable and help with our climate action problem. This doesn't necessarily start in the cafeteria. It could be as simple as changing the heating system or the AC system. But there are so many ways campuses can become more sustainable throughout the world that I think this idea of sustainability box would really help achieve. Finally, I just want to say thank you to all the people that let me interview on Quantum Black by McKinsey and Company, the UCLA professor, Shed Aquarium, McKinsey and Company, who kindly let me interview 5 of their members, the Lawrenceville School, and of course Polygence for making this all possible. But what exactly did I make? So this is my website called Sustain. Sustain is the website I made with all the podcasts. Here is the homepage many will open when they come to see my website. We have a giant title right there that says Sustainability and AI. We have a brief description on my project, connecting the dots between sustainability, marine conservation, and AI through inspiring podcasts. From a college professor to a former CEO of a major tech company, listen to see how major listen to see how the world is evolving, what they and what we can do to advance global sustainability, marine conservation with the help of artificial intelligence. Below my intro, I have my 10 episodes on the podcast. Dr. Laura Cushing of UCLA, Kia Giovanni of the McKinsey & Company, and so on. Right now, they are all on the website just for your view. However, once I am able to, I'll take this down, I'll upload once a month, and eventually it'll look the exact same after 8 to 10 months. I also have my contact page at the bottom of every single page. At the top, we have a drop-down bar. The next tab is an About Me. I've explained this a little bit, but it's a little bit about me, how I got into sustainability and AI, how this all started. It also mentions what is exactly Polygens and my mission statement, what I'm actually trying to achieve with this project. So my mission statement for this project is to help educate, inspire high school students and college students about the importance of sustainability, what they can do to make a real difference in their local communities and more broadly for the world. We are the next generation that will be most impacted by climate change over the next 50 years. So it's up to us to make a difference in order to do so. We'll have to leverage the learnings from the past, think about new technologies such as artificial intelligence. They'll help advance the thinking solutions that drive for sustainability efforts. Through my podcast, I noticed that there was a lot of key terms, not even I really was able to understand. So I decided to make a key terms page based off of an online website for AI and sustainability. This one was made by Clever's Green Glossary. It's 40 or so key terms that are important for sustainability and a few that are mentioned by some of the interviews. So listeners have a better understanding. We also have an artificial intelligence key terms page with the exact same goal. These terms were made by TELUS International, and a few of them I added myself as they are mentioned constantly throughout the podcast, and I thought it'd be a good idea for those to know exactly what the interviews are saying, as at times it does get confusing. And then the final tab of my website is my journey through photos. My journey through photos explains basically my about me, but through photos I've taken or photos off of the internet of me and the work. So I have my description above. I have the shed aquarium where I interned over the summer. I also have 12th Street beach cleanup where me and the other interns, we organized a beach cleanup right behind the planetarium in Chicago, which is a very populated beach, and that was a fun beach cleanup. I then have the Sea of Cortez, Mexico, where I did my student travel trip. On the picture on the left, it was me and the entire group along with a few leaders. We went to a local school. We painted recycling bins to encourage recycling. We cleaned up the environment. We planted trees, and we also had fun with the children. On the right, we preserved at-risk habitats in our camping site along the mountains and along the coast of Sea of Cortez. Finally, we have the Lawrenceville School, which is the school I currently go to for high school. On the right, we just have a normal picture of the school and below I explained how the school takes a holistic approach to sustainability. On the left is the main form of sustainability at my school, which is called the Big Red Farm. The Big Red Farm is a farm directly related to campus. It houses 24 acres of solar panels and provides most of the food we get in our dining hall, making it more sustainable. And eventually, over time, whenever I finish sustainability in the box, there'll be an additional tab I will add to my website with a full listed out. I really want to thank you all for your time and listening to me ramble on about my project. And once again, I really want to thank Polygens for helping me bring my passion to light with this project.
Hi, I'm Matthew Grupenhoff, and I'm going to be talking about key replacement through certificates in one-time hash-based signatures for post-quantum cryptography. So to start, hash functions are these special functions where the input data is any length. It could be 0, it could be really long, but the output is always the same length. So for example, the SHA-1 hash function always gives you a 20-byte output. And if two outputs the same, you can almost guarantee that the inputs are the same, which is the property of collision resistance. And also, if you're given an output, the other thing is you can't just find the input easily. It'll be a lot of searching. So another thing is public key cryptography, where you take one key called the encryption key and you have some data, and then that data becomes this ciphertext that you can't see without using the other key, which is the decryption key, which converts it back to the message. So depending on why you're using this, you might share one of those keys or you might share the other. So whichever one you share is called the public key, and the private key is the one you don't share. So for example, this could be used in a case where you want anybody to be able to send you something and encrypt it, but only you can see it by decrypting it. So these can be combined to get something called digital signatures, which is where you have a message, anyone can see that message, but you can also verify that message came from the right person. It's usually a combination of hashing a message and then encrypting it through the public key cryptography. So everything so far seems secure, but in 1994, Peter Shor came up with an algorithm for quantum computers, not classical computers, that breaks a lot of these public key cryptography schemes, such as RSA, DSA, and ECC, which are all very widely used. But the other things, like one key encryption or symmetric encryption, is still safe, and hash functions are still safe from this. And while there are attacks in theory for this, those are really easy to fix by just doubling the length of your key or the length of the hash, and then it'll be safe again. So there are a lot of approaches to make signature schemes that are resistant to quantum computers. And one idea is just completely using hash functions. So what you end up doing is you need to give away part of the key when you sign something. And that's the basis of all hash-based signing. So there's Lamport and Winternitz, for example. And the whole idea behind this is you can take a private key, convert that to a public key by hashing parts of it. And then the person can verify later when you give the relevant part of the private key that isn't hashed. And Lamport and Winternitz are variants of that. But the thing is, you can only really use those a few times before it becomes insecure. So some people started creating these compound schemes that combine a lot of keys together in a secure way. And then these can only still be used for a finite number of times, but it's still a lot more. So if we wanted to make the keys infinite use, then what you could do is you could follow a certificate-like style where you end up taking one key and then you can sign a new key with that together with the data. And then when you want to sign another piece of data, you take that new key, you sign in the third key together with the next data, and you can sign an infinite number of things that way. So this right here is the theory of that. You would have keys, and then you'd have the public key already securely arranged. And then you would hash the data and put that with your signature together with the new public key. And then you just encrypt all of this using the hash private key system. And then you could take this new key now that it's agreed on, and it could sign this next data and so on. So that's a theory, but the small problem with this is the key sizes. Because the key has to, under Lamport, the key has to be twice the size of the signature, but that's not an option here where we're putting a key in the signature unless the key is going to get really small. So to get around this, instead, we need to hash the key here and store that in here, and then send the key on the side. Which this isn't a huge change, but it is something that makes it slightly more complex. So the security of this actually becomes mainly dependent on the security of the hash here, which goes into that log, which that b sub h plus 2 generally is approximately b sub h. And then that b sub h is the number of bits in the hash, which is usually much bigger than 2, so the 2 won't have much of an effect. And then the BK is the size of each Lamport private key entry, because the Lamport private key is a bunch of numbers. So that would be the number of bits in each number. And so by plugging in 512 for this security level, the security level ends up being roughly B sub k plus 8. So these are the signing times right here. It's pretty clear that Lamport is slower than schemes like RSA and DSA and ECDSA. But it's pretty clear as well that once it grows, the security grows enough, it actually becomes faster than RSA, which means none of these times are super unreasonable for signing. On the other hand, verifying is a special case for RSA, because RSA can usually verify really fast because there's a certain constant that normally gets set to 65537. And that means none of these times are super competitive. So for this data collection, instead of using 65537 for that, it became set to 2 raised to the number of RSA bits minus 1 plus 1, which makes these times more comparable. And it's clear that RSA is still longer time than Lamport once this is applied for verification, which still means this time isn't unreasonable for Lamport with this key replacement as the security level grows. So with this in the future, another thing that could be done is applying this key replacement to some of those full hash-based signature schemes by allowing several pieces of data to be signed instead of just one. And then a similar thing could be done where a bigger key from that compound scheme could be passed down. So this could be applied to XMSS or Sphinx, for example, as described earlier. And that would remove the finite restriction on these schemes. So thank you very much to Dr. Xiaodong for the project guidance. He had lots of knowledge about the research world. He was super familiar with how to design and test cryptographic schemes. And he was just really patient. I was brand new to research on my way in, and he really helped me with this. And also thanks for Polygents for just organizing this to begin with and providing this great opportunity. And thank you for coming.
Hello, my name is Rishabh Prabhu, and today I'll be talking about analyzing the outcomes in turn-based games. So why do we need to analyze the outcomes in turn-based games? To analyze the outcomes in turn-based games, we have to teach a computer to be able to choose between choice A and choice B. And in the future, having a computer be able to choose between an A and B in many different scenarios is going to be extremely useful in the development of AI. Also, specifically in the case of Pokemon, there is a luck factor involved with these calculations. So some other factors are that computers capable of playing turn-based games are usually very complex and require a team to run and develop, or they're very shallow and rely on basic input-output in certain situations and are very exploitable and have major design issues. Another major issue is the lack of accessibility. Not a lot of people can actually get their hands on computers capable of playing games that are actually capable of winning and playing the game correctly, and they struggle with more complex games. So what is data science? Data science is the form of analyzing data, and that's how I was able to get the conclusion from this project. So the first step in data science is to collect the data. So to collect the data, I used Python. Collecting the data is really important because data science is about analyzing that said data. The second step in data science is cleaning the data. When you collect data, there's going to be a lot of junk data that you need to get around. So cleaning the data efficiently is really important because of the mass excess of data you will have. I also use Python for this portion. The third step is the exploratory analysis. Performing an exploratory analysis of the data and looking for trends and patterns within the data is really important. Python will use for this portion, and some of it will be shown using matplotlib and Seaborn. Step 4 is modeling. To have points to back up your conclusion, you're going to need a model or a graph to show what your data points actually show. This will be also done using Matplotlib and Seaborn. Collecting the data. The data was collected from Pokemon Showdown, a well-respected Pokemon simulator used by many players for competitive battling. Pokemon Showdown has a very strong reputation of the most used Pokemon battling simulator with its own competitive formats run by Smogon, another very well-respected group in the Pokemon community. So cleaning the data. This is the text data from a single match, totaling over 10,000 characters. To clean this data, I used a parser made in Python to effectively analyze the core pieces of the data. And I was able to collect and analyze over 20,000 matches worth of data. On to the exploratory analysis. Right here, I have a bar graph showing the win rate of the top 10 most used Pokemon in Gen 8 OU. An important thing about the dataset I used is the matches were only taken from top players within the top 500 of Gen 8 OU players. So at the far right, we have Landorus, the most used Mon in Gen 8 OU. At the far left, we have the 10th most used Mon in Gen 8 OU. As you can see, all of these numbers seem to be around 0.5, which makes sense since there's one winner and one loser in most cases. But you can see that even though their usage rates are high, which would make you think they're strong Pokemon, some of them have some low usage rates below the 0.5 threshold. Onto the modeling. Here we have some graphs made using Matplotlib. On the left, you have a graph showing the win rate of all Pokemon used by top players in Gen 8 OU. As you can see, there's a large amount of clumping around 0 because of the major fluctuations, as one could use a Pokemon in one match and win that one match and have a 100% usage rate, or play one Pokemon in one match and lose that match and have a 0% usage rate. As you can see, those very few dots near the very bottom left. You can also see to the far right in that graph, we have an outlier, which is Landorus for his excessively high usage rate due to his strength and versatility. The linear regression of this graph shows that it's a positive slope on the line, showing that on average, as the usage rate increases, so does the win rate. On the right, we have the graph of the top 100 most used Pokemon by top players. As you can see, there are 2 outliers to the top left and only 1 outlier to the bottom left. And you can also see that the slope of the line has flattened out a lot more, showing that the win rate doesn't really fluctuate in the top 100 Mons. Onto the continued part of the modeling. I will be discussing some of the strong outliers in this graph. The very top left, we have Necrozma and Weezingala. While these aren't that heavily used, the people using them are top players with a very high skill level and have used their niche to a strong extent. Seismitoad is a weird outlier because you wouldn't really expect him to be that high up, while Mew you'd expect to be much farther to the right because of its strength as a strong lead. Ferrothorn and Landorus T are well-known Pokemon, as you can see by their high usage rate. Overall, this graph shows that specific Pokemon with specific niches or strengths and versatility are strong outliers, as you can see by their high win rates or high usage rates. Thank you for listening.
Okay, let's begin. So, hi everyone, my name is Pierre, and today I'm going to talk about my computer science research project, which is about generating musical accompaniment to melodies, and this using deep learning, and I'm presenting a VAE neural network model. The motivation behind this project is very simple. We know that not everyone's a Mozart, but most people can still differentiate good music from bad music. And what we're doing here is that we're providing a tool for music amateurs or beginners to generate some music. Also, state-of-the-art models are focusing on generating music from scratch, from zero, but we added a user-given melody constraint. So the melody is imposed by the user. And we did this because we wanted the user to feel free and connected with the music he creates, even when he's using our tool. At the end of the day, music remains something artistic, intimate, and for us, the main melody had to come from the user itself. And that's how we came up with the following idea. The user would be able to input a simple melody into our tool, like a one-handed piano melody or something very simple and basic. And our deep learning model would generate the whole musical accompaniment to it, including guitars, bass, strings, and drums. So basically, from one instrument, we generate the other four. And so the first question we had to address was, how do we transpose music to numbers for our deep learning models? Well, for this, we use the LAC piano roll dataset, which is a MIDI dataset. And it works like this. So we know that a piano roll looks like this on any music mixing software. And we represented this information as a two-dimensional matrix where a column was a time step and each row was the pitch of the note played. So if you want to compare this to the piano roll, you can see that there's some similarity. And so if a note is played at time t and pitch p, then the matrix entry at column t and row p is the velocity, so the volume of the note, and otherwise it's 0. There are 128 note pitch possibilities, which cover from C1 to G9, and the temporal resolution is set to 24 per bit in order to cover some common temporal patterns, such as triplets and 32th notes, for example. This means that in each instrument, each beat is a 24 times 128 matrix. And for example, a bar in 4/4 time would be a 96 times 128 matrix. Since we have 5 instruments to cover, which means 5 tracks, the whole multi-track piano roll will be a 5 times 96 times 128 matrix for a 4/4 beat once again. Okay. So music data can be described with a matrix. Now let's talk a bit about deep learning model itself. So the model architecture is looks like this. So we first have to decompose the big music matrix into some smaller sequences of length 32. So that's just the music sequence. We remember that one beat is length 24, and we chose length 32 for our sequences because that allowed some more fluid transitions between each beat. We didn't want some jerky music. And once music is decomposed into smaller chunks, we are using 2 different models here, which are VAEs and neural networks. So firstly, what the VAE is doing is that it's trying to simplify the data and extracting the most important features. Basically, it's reducing the dimensions of the data matrix into some easier to process ones, while trying to lose the least amount possible of information. And this is what we call encoding. So VAE can encode, but also they can decode. And decoding is basically reconstructing the original matrices from the simplified ones. So for example, here WT represents a simplified matrix, and we're using the VAE to decode it into the original music matrix. And so after this, the outputs of the VAEs are passed into a neural network. Here we took the example of guitar. So guitar NN is the guitar neural network. And this is where the music is actually being generated. Basically, to generate the accompaniment at time t, so here, we pass in 4 informations. The melody at time t-1, t, and t+1, so the previous, current, and next melody. So that's what's come from the user. And the previous accompaniment. So generally it would be the previously generated accompaniment. And all these informations are passed into the guitar neural networks, which outputs a WT matrix, which is a simplified matrix, and then the VAE decodes it into the music matrix. We then repeat this process, of course, iteratively for future time steps, and this allows the generation of music. So let's talk a bit about the training process now. To train the VAEs, we used a 2-term loss function, a reconstruction error, which calculates the difference between the decoded output, so here x hat, and the inputs, so x. And another term is the regularization term. So we ensured that each encoded vector, so our latent space, was close to a standard Gaussian, and that was to avoid some severe overfitting of our VAE. Then to train the neural networks, we selected over 1,500 songs from the LAC piano roll dataset. And these were labeled as pop or soft rock because we found that these were the most complete ones. And also we restricted the genre because we assumed that if the dataset was too diverse, then the neural network wouldn't be able to learn any common pattern or structure among the music. For example, if a model trained on both classical and metal music, then of course it would be hard to learn anything. And then we trained the neural networks by comparing the outputted accompaniment to the original ones from the original songs. So basically, we pass in the melodies of the songs and we expect them to output the original accompaniments. And that's how we calculate the loss of our model. Basically, the closer our generation was to the original song, the smaller the loss. But this was just to let our CNN, our NN, sorry, learn the mapping of patterns and structures, of music. And we ensured that the training and testing sets were different, just to see how our model performed on never seen sample. Basically, we didn't want our model to just mimic existing music. We wanted it to create some new accompaniments. The architecture itself of the neural network was just two fully connected layers with a ReLU activation in between. So it looks like this. And when training done, our model was ready to generate some music. And to show the results, I think the best way is basically to show the music generated, because I chose some examples of melodies and outputs. And let's hear first a single-handed melody that I played on my electric piano to see how it looks like. So that's a very simple melody of piano, sorry. So you could assume that the user passed this as an input. And so the output of our model would be like this. And I also chose a second example. So this time the piano melody is a bit more rich. So the input has a bit more notes, and let's see how it looks like. And so if I pass this into our model, the output would sound like this. So as you can hear, these were two very different play styles, and our model was able to successfully generate accompaniments for both of them. So yes, of course, not all the notes are on point. Sometimes there are some notes that sound a bit wrong, but overall, the model was still capable of generating some meaningful accompaniments to the melodies. And so in conclusion, we were able to create a new type of model that generates meaningful accompaniments to user-given melodies. It follows a VAE/neural network structure, which allows it to not simply mimic existing music, but find the underlying patterns, which was really interesting. However, some perspective of improvements are the limitation of the MIDI format, because remember, our dataset comes MIDI format, and we know that our model uses MIDI as input and output. And MIDI is not the best sounding music. The user would have to edit and mix the MIDI file into maybe a better MP4 file to get some better results for his own music. And also another downside is that iterative generation doesn't really allow for a macro structure within the music. So there would be no introduction and no outro in the music itself. Also, there's a risk of domino effect, which means that if, for example, at time step T, the generation is not good enough, then the future time steps might be altered by this and would sound quite terrible if there's no strong basic. And that's, of course, not what we want in music. And so overall, our project still turns out very successful in generating some 4-instrument accompaniments to simple melodies. And something I want to say is that what truly makes the field of deep learning amazing is the open source and collaborative culture of our deep learning. Our work would never have been possible without many generous contributors before us who documented and researched on the subject. And also a very special thanks to my mentor, Shamik Verma, who taught me a lot of things and without whom this work would never have been possible. Thank you for listening to me.